Okay, so as you've, I kind of told you we're starting a new topic, right, with matrices, but I haven't really told you anything about matrices. I've just given you these three questions to have a go at. And the reason why is because matrices are really, really useful applied to situations. Okay, so I'll talk a little bit more about how matrices are useful a little bit later, but I thought the best place to start was actually applying them to situations which are suited to involve matrices. Okay, so if we have a look at question 1, I've given you two tables. Okay, so I've said the tables below show the amount of sandwiches sold in a school canteen in 1 week. So that's this table here. So for example, on Monday, there was 1 pickle sandwich sold, 2 falafel sandwiches sold, and 5 cheese sandwiches sold, etc, etc, etc. And also the cost of each sandwich. So pickle sandwiches cost £3, falafel cost £4, and cheese costs £2. You need to find the amount of money taken per day. So in other words, I'm expecting you to find another table that takes these two tables and condenses it so that you just have, for Monday, this will be the cost. For Tuesday, this will be the cost. Wednesday, and then cost. Thursday, you've got the cost. And then Friday, you've got the cost as well. Okay? So, how do we go about doing this? Given that I tell you how much of each sandwich, the quantity of each sandwich sold per day is, and the cost for sandwiches, how do I go about working out the amount of money taken per day?
Just multiply.
Okay, so what am I multiplying? To find the cost for Monday.
1, and then the cost of the pickle.
Absolutely. And then?
And then the falafel, and then the cost of the falafel, and then the cheese.
Absolutely.
And add the total together.
And then you add them all together. Okay, so let me just write that down, okay, so that we've got it on the board, okay. So for Monday, I'm literally going to take the amount of sandwiches, the amount of pickle sandwiches sold and multiply it by its cost. Then I'm going to take the amount of falafel sandwiches sold and multiply by the cost. Because of course, if there are 2 falafel sandwiches sold, they each cost £4, then in total I've got 2 times £4 sold in terms of falafel, right? And then I take 5 and multiply by 2. And then you're absolutely right, to get the total cost, I just need to add it all together. Okay, so what's the number that I get here? 21, fantastic. Okay, and then for Tuesday, you're happy it's a similar kind of a thing. So I just look at the Tuesday row, I take each of the pickle, the falafel and the cheese quantities and multiply by the corresponding costs. Okay, so it will be 6 times by 3 plus 5 times by 4 plus 10 times by 2. So what's the amount of money which we've taken? 58, yeah? And so on and so on and so on. So you're happy for Wednesday, it'll be 0 times 3 plus 3 times 4 plus 5 times 2. Okay, so how much money was taken? £22. Okay, for Thursday, it'll be 7 times 3, 8 times 4, 0 times 2, which is £53. And then for Friday, it'll be 8 times 3, 0 times 4, and 1 times 2. 26. Perfect. Is that okay? Okay. Now, this is kind of quite weird, okay? Because what a matrix is, okay, is just simply a table of numbers. That's all I want you to take away from what a matrix is. It's just a table of numbers, okay? And in fact, I actually put these tables in context. In reality, when you're dealing with matrices, you don't have them in context. So in other words, you just simply get given this array of numbers, this table of numbers. And in fact, we tend to write matrices with brackets around them, okay? So that's how I would usually give you that, okay? And then, same thing, take away the context, and just simply give you the numbers, give you the elements. Take that, and I'm just asking you to multiply them together, and the result would be this table here. Okay, would be this table here. Does that make sense to everyone? Okay? So what I'm literally doing is saying a matrix is just a table of numbers. In reality, so for example in the exam and when you're dealing with mathematics, because you understand the operation, because you understand how to combine these two things together, you don't need the context anymore. You don't need the context. So I strip it all away and just deal with the individual matrices, deal with the individual elements. And then the way to combine them together would be this element times this element, plus this element times this element, plus this element times this element. That gives you that element there. Is that okay? And then to find this element here would be this element times this element, this element times this element, this element times this element. That will give you that element there. Is that okay? So what I'm literally saying is matrices are just tables. They could have context around them, okay? But you don't need that context in order to multiply them together, okay? You just strip away all the context, you get given these two things to multiply them together, you do this kind of weird operation, okay? Now the reason why I say it's a weird operation is because it is. Like if I just presented this to you and said, right, the way to multiply these two matrices together is you take this times this plus this times this plus this times this, you'd be like, what? But if I put it in context, you realize it makes complete sense, okay? Makes complete sense. So this is something called matrix multiplication, and you need to be aware of how to do it. Now, a couple of things that you need to sort of watch. First of all, the dimensions of the matrix, So we always write the dimensions of a matrix as the number of rows times the number of columns. Okay, so we say it's this many rows by this many columns matrix. So for example, for the first one, for the first matrix, this matrix here, how many rows have we got?
How many rows?
5, right?
3.
Rows.
Oh, rows.
1, 2, 3, 4, 5, okay? How many columns? 3. 1, 2, 3. So we would say that the first matrix would be a 5 by 3 matrix. 5 by 3 matrix, okay? What about the second matrix? How many rows?
3 times 0.
3 rows. How many columns?
1.
1. So it'd be a 3 by 1 matrix, okay? And what we're literally doing is multiplying these two things together. So we're taking a 5 by 3 and multiplying it by 3 by 1. Now, we can do this for one very particular reason. You notice that the number of columns of the first matrix has to match up with the number of rows of this second matrix, okay? So for example, if we stuck an extra number down here, for example 1, okay, this would now become a 4 by 1 matrix. You can't do that anymore. Okay, you can't multiply them together because you're like, right, this times this plus this times this plus this times this, and then you've got an extra element which you don't know what to do with. Okay, so you have to make sure, if matrix multiplication is valid, that the columns of the first matrix has to match with the number of rows of the second matrix. Okay, if they don't match, you can't do the multiplication. Okay, because it doesn't make sense otherwise. Now, have a look. What are the dimensions of the second matrix, of the resulting matrix, sorry?
Dimensions.
Yeah, what are the dimensions of this matrix?
So it's 5 times 1.
Yeah, it's a 5 by 1 matrix in the result, okay? Now, I could have forecast that before I started, okay? Because have a look up here. I say these two numbers have to match in order to do the multiplication. But have a look at the outer two numbers, the 5 and the 1. That should be the result of the resulting matrix. Because I'm literally saying 5 rows and I spread it across one column. Does that make sense? Yeah? So the resulting matrix should be 5 by 1. So in other words, if I wanted to do this generally, if I have an n by m matrix and I try and multiply it by an m by p matrix,
The result should be NP.
exactly, the result should be, well, first of all, these two dimensions have to match in order to do the multiplication. Then the result should be an n by p matrix. Okay? Is that okay? Is that okay? Good.
So is there going to be a question like, testing us if this is going to work, like you can give us...
Could be. I mean, have a look. There's 3 pages here, right? These inner 2 pages, sorry, picks up too much. These inner 2 pages start to get into, can you do this matrix multiplication or not? Yeah? So for example, look at question 3. Okay? I've given you 5 matrices there, and I've just said, list all possible pairs which matrix multiplication can be done. Yeah? But for the moment, let's just really get into our heads the hardest concept with this. How do we do the matrix multiplication? So can I draw your attention to this side of the board for me?